Okay, my friends, so you've opened up our little spreadsheet here, and in this, you've got in column A, you've got all the states, including the District of Columbia, Washington, D.C. So you've got 51 different elements here, and at the bottom, I've got a little space called All States, and what that's going to keep track of is the entire United States data. Okay, column B is just the population of each of those states. And then again, at the bottom, you've got the entire population of the United States, which might differ a little bit from if you Google it today. All of this data, just so you know, is if you look down on the bottom right of my computer, is accurate as of January 13th, 2021. Okay. And then next to that, in column C and D, we've got as of this date, January 13th, you've got the total COVID cases for each of the states. So Alabama, for example, has 404,000, and then also the total deaths attributed to COVID in that state. So Alabama has 5,347. Okay, and that's for all the states. And then once again, at the very bottom, you've got all the U.S. numbers. And again, these are going to be changing constantly. These were accurate as of the last time I pulled them down from the CDC. Okay, what we're going to do is we're going to look at some rates that keep showing up in the news, and we're going to kind of play with those a little bit. Case rate per person. Okay, it's tempting to look at the total cases in column C and say something like California has the absolute worst COVID record because look at that, 2.7 million cases of COVID. That's so much worse than Alaska. Alaska only has, 49,000 cases. And you can say that. That's totally fine. But the problem with that is you also have to look at how many people are in the state. California should have more cases of COVID than Alaska. It's got more people than Alaska. As a matter of fact, it's got 2 million more people that had COVID than Alaska has people. So a fair way to look a lot of data like this, and not just COVID data, but any data, is called per capita, per something. So you look at the numbers divided by a common number in each of the sets. In this case, we're going to take the total cases in a state and divide it by the population of that state. So we're going to do that using Sheets. So click in cell E2, and we're going to type a formula. And we may have talked about this already. If we did, I apologize for repeating myself. But to do a formula, you're going to type an equals sign first. And what we want to do is we want to take the case number. So I'm going to click on C2 and then hit divide and then click on B2. And what this is going to do is it's going to take that total case number and divide it by the population. And this tells us that there are 0.08 cases per person in Alabama. We'll come back to that in a second. Now, what's cool about that is you can now drag that formula all the way down. So what I'm going to do, I'm going to show you a cool shortcut if I haven't already shown you how to do this. If you double click on this little square right here, it will autofill that all the way down to the very bottom. Now, Alabama has 0.08 cases per person. Alaska has 0.07 cases per person. Arizona 0.09, and so forth and so on. Now, because these numbers are so very small, all of them, I don't see anything that's even close to, oh, there's one. Yeah, North and South Dakota actually have the highest right now. 0.12 per person and I think, where's the other one? South Dakota. 0.12 per person. Yes, exactly. The other measurement that is used, I shouldn't say the common measurement that is used is not case rate per person, it's the case rate per 100 people. So what we're going to do is, in this column here, we're just going to do equals that times 100. And that'll increase it as a fraction to per 100. And if I hit enter then and drag it down, it's the exact same numbers that you see over here, except these numbers are now per 100. Now, some of you might be looking at this and going, wait a minute, Sean. Before, I saw that California and Alaska were both 0.07, and now this one's 6.67 and this one's 6.86. They're not the same. You're right, they're not the same. That's because these numbers here are rounded off to 2 decimals. But a cool little spreadsheet trick, if you select some numbers and then use this button here, you can get more decimal places. So you can see what happened over here when we bumped these over. We got a couple extra places that we didn't see originally here because they were hidden by the rounding. So you could increase the places there to see that. So now you would say the Alabama case rate is 8% in the general population. Alaska's case rate is 6.67%. Arizona's is 8.62%, and so forth and so on. What's the entire case rate for the whole United States? 6.68%. It's almost exactly what it is in Alaska. So Alaska is mirroring the U.S. as a whole. Okay, so that's the case rate. So that's the number of cases divided by people and then changed into a percentage there. Now let's look. We're going to scroll over this way. And you may have noticed something. I've set up the spreadsheet it's called freezing rows. We're actually keeping the states here so you can keep watching. Death rate per case. So this is still going to be a per capita. Again, it's tempting to look back over here and say, okay, which state has the most deaths? Florida, 23. Oh, God, California, 29,965. Okay, yeah, they got the most deaths, at least in what I can see right here. But also in what I can see right here, they have the most people. So they should have, all things being equal, they should have more people succumbing to the virus. So let's see if it pans out numerically. So for the death rate per case, we're going to go equals. And we're going to take the total deaths and we're going to divide them by the total number of cases. And we're going to press enter. And we're going to copy that down to see the death rate. Now, I know that what you see right here in Alaska might be confusing. It says 0.00, which makes you think that nobody died in Alaska, which you know is not true because they did right here. And that's just, again, a rounding problem. It's just a very small number of people have died overall compared to a small population. So again, I think we should do, once again, a death rate percent. So we're going to take that last number and we're going to multiply it by 100, and that's going to change it to 1.32% for Alabama. I'm going to drag it down one here. About a 0.5% for Alaska, and we can drag this all the way down, all the way down. So California does have a higher death rate than Alaska. And you could actually say it's just a little bit over double the death rate because it's more than 1% versus less than 0.5%. What's the whole United States death rate? About 1.6% so far. 1.6% per case. That's not per person. That means of the cases that are reported, about 1.6% of those cases then result in a death. How does it look when you look at it per person? Let's take a look. So we're going to take equals, we're going to take the total number of deaths, and we're going to divide that by the population of the state or area. All right, and again, it looks like it's 0, but that's just because it's a very small number. Drag it down. Oh, look at that, lots and lots of zeros, and oh my goodness, they're all 0 because they're all so small. So again, let's bump up the death rate to per 100 people. And we'll see some actual digits show up. There we go. Oh, there they are. There they are. Is anybody still double zeros? No, nobody's still double zeros at this point. Now here's the catch though. Because these are still extraordinarily small, even when turned into a percent, the death rate from COVID is not often spoken of in terms of per 100 people. It's usually spoken of in terms of per 100,000 people. So what we're going to do is we're going to go equals. We're going to take the original death rate and multiply it by 100,000. And then we're going to drag that down. And there you end up with the death rate per 100,000 people. And you know what a lot of media sources will do is they'll actually take those numbers and make them rounded off to just one whole number, to the nearest whole number. And you know what I'm going to do while I'm down here? I'm going to fix this and make the background match the other one. That's bugging me. I'm sorry. It's a little silly that it's bugging me. But I want the background color to match just because I want you to realize that is the entire United States. So in the entire United States, 106 people per 100,000 have died due to COVID. Per 100,000 people. You know what I think we should do right now? Let's take a pause right now And let's take a look at the math I just did to make sure that you understood why I was multiplying these by 100 and why we were multiplying these by 100,000. Let's take a quick look at the chalkboard. Okay, friends, so let's just look at Alabama. The same thing works for any other state or even the entire United States or any country for that matter. It doesn't matter. So in Alabama, based on my data I just saw, there were 5,340, or there have been 5,347 deaths due to COVID over the entire population of 4,903,185. Now, if you divide this number by this number, you will get, I can't remember these many digits in my head, I have to go look it up, you will get the number 0.001091. Let me check to make sure that's right. Yes. And that's deaths per person. And this is the part I think people forget. It's this many deaths per one person. That's the catch. When you divide two numbers in a calculator and it spits out the result, that result has a denominator of 1. And this is important because when you start trying to change these things to percentages and per 100,000, you have to know that there's a 1 there. For example, when we changed the number in the spreadsheet to a percent, you might remember that I multiplied this number. Now remember, you didn't actually see that entire number. You only saw that in the spreadsheet because it was only rounded off to 2 decimals. But we multiplied this whole number by 100. And that turned it to 0.109, 1091, I guess. But to keep the fraction the same, you also have to multiply the 1 by 100. So it's over 100. Now you don't actually see that in the spreadsheet. You take care of that by saying percent. It's that number, percent. When you say percent, you're actually creating a fraction, which I think a lot of people just forget. We get so used to saying these things, percent per 100,000, that we forget we're actually making a fraction with a different denominator. But you are. And you don't have to be limited by just percents. You can have per anything. If you were to multiply both of these by 10 again, let's just do it. Times 10. This would move over one more time and it'd be 1.091 per 1,000. We don't have a fancy symbol for per 1,000, but it absolutely can be used as a denominator. And you can go to 10,000 or 100,000. And each time you just multiply by 10. If you multiply by 10 again, you'd end up with 10.91 per 10,000. I'm running out of board. And then if you multiply by 10 one more time, you'd end up with, I'm going to have to go, follow my arrows here. We're going to have to come up here to create some more space. Multiply by 10 again. And you're going to have 109.1 deaths per 100,000 people, which is exactly the unit we have in the last column of our spreadsheet. So if you follow the multiplication, times 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. That's why I multiplied by 100,000 in the spreadsheet, to get it per 100,000 people. And because this number is easier to chew on than this one, and I think most Americans are a little bit math phobic when it comes to decimals, that's why we end up using per 100,000 for extraordinarily small rates of things like COVID. Hopefully that makes sense. Let's look at a little bit more in the spreadsheet, and then we'll try some questions. Okay, my friends, so now you know why these fractions have the denominator of 100,000 like they do. The last thing I want to show you is how to sort data, because I'm going to ask you a number of questions next about which states have the highest rate per whatever, lowest rate per whatever. I'm going to ask you a whole bunch of questions about that. So what you want to do in order to sort, I'm going to show you with population over here because it really doesn't matter which one we use. And at the beginning of any column, when you put your mouse on top of the column like this, a little arrow shows up over here in Sheets. If you click that arrow and then come down here to sort, you can sort ascending or descending. If you sort ascending, let's do it this way. What it does is it takes all the data in that column and then puts it in increasing order. So now you've got the states in increasing population. And what's totally rad about that is everything else comes with it. The total cases, the total deaths, the name of the state, and all the rates you calculated. You can also sort the other direction, descending. And when you do that, it does exactly the opposite. We start at the United States, which makes perfect sense, and then it goes downward. California is the most populous state, followed by Texas, followed by Florida, blah, 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 blah. And you can sort any column you want. So and you can also undo a sort. I'm going to show you, you can use the undo button here, or I always use the control button held down and press Z. If I undo it twice, I'm back to where I started. And you can sort any column. You can sort by the number of cases. That shows you that California has the most cases, followed by Texas, followed by Florida. You could also sort by the number of deaths. California has the most deaths, followed by Texas, followed by Florida. Kind of fun. Well, not talking about death, but it's kind of fun that we can do this. And then you could also sort case rates, death rates. You can sort anything in a spreadsheet. Okay, that's going to get you started. Let's do some more questions.